Module 12.2, Definite Integrals of Trigonometric Functions. Objective 1, determine the definite integrals of trigonometric functions. Objective 2, use definite integrals to solve real-world applications. Objective 1, find the definite integrals of trigonometric functions. Example 1, here we have the integral from pi over 3 to pi over 2 of cosine x dx. So just like we did with indefinite integrals, we're going to take the integral of cosine, which is sine x, and now we're going to plug in the values between pi over 2 and pi over 3. So we rewrite this as sine of pi over 2 minus the sine with pi over 3 plugged in. Sine of pi over 2 will be equal to 1. Minus the sine of pi over 3 would be around 0.13. So that should give us 0.87 approximately. And we have now taken the integral of this function. In our second example, we're wanting to find the area between the function and the x-axis. Alright? And we're looking at sine x. So sine x between 0 and pi will look like this. And we're going to be looking at somewhere in here where it reaches its maximum point, which is pi over 2, and we're going to be looking at somewhere in here, which is pi over 3. And we're going to find the area in this. Okay, so let's go through and take a look at this. So if we take the integral of this function, we're going to end up with negative cosine of x, and that is going to be between pi over 2 and pi over 3. And so that would be negative cosine of pi over 2 minus a negative cosine of pi over 3. And that's going to give us 0, and then the 2 minus will give us plus, and we've got 0.5, so that would give us around 0.5 for the area. Objective 2, use definite integrals to solve real-world applications. Example 3, sales of snowblowers are seasonal. Suppose the sales of snowblowers in one region of the country is approximated by S of t, which is equal to this trigonometric function, where t is time in quarters of a year, with t equals 0, responding to the November-December quarter. Okay? Use a definite integral to find total sales over a year. We're going to integrate over 4 quarters, so it's from 0 to 4 quarters of this function. Okay, now this function tells us the sales over the immediate period. So to find it over a period of time, we're going to integrate. Basically what we've got here is 2 integrals. We have the integral from 0 to 4 of 5 dt plus the integral from 0 to 4 of the second part, which would be 5 cosine pi over 2 t. Well, this one's going to be easy enough. That's going to end up giving us 5/10. We'll look at it in a second. But this one, we're going to need to use a little u substitution. So let's come over here for a second, and let's plan on writing u equal to pi over 2 t. And then therefore, our derivative of u would be equal to pi over 2 dt. And if we flip this, that would give us dt is equal to du times 2 over pi. Alright, so now that we got this, let's concern ourselves with the second one, and we'll worry about the first one in just a minute. So the second one, we're going to end up with the integral of 5 times cosine of u, and then we're going to put du times 2 over pi. And then if we take a lot of this stuff out, that should give us the integral of, and we put the 5 and the 2, that'll give us 10 and pi out front. We've got cosine of u du. And remember that our integrands, let's put in our integrands here from 0 to 4. So we're going to start putting those back in. So that's going to be equal to 10 over pi times, and the integral of cosine is sine of u, which our u was pi over 2 t, and that is going to be from 0 to 4. Now, if we integrated the first part, let's go ahead and put this up here. So we're going to end up with 5t from 0 to 4, because the integral of 5 would be 5t, and we're going to integrate that from 0 to 4. Okay? Plus, let's go ahead and start plugging our numbers in here. We've got 10 over pi, and this is going to be times the sine of pi over 2 times 4 minus the sine of pi over 2 times 0. And in the first part, we're going to end up getting 5 times 4, which is 20, minus 5 times 0, which is 0. So we've got 20 for the first part, plus, and if we break out our calculator and do this second section, we're going to end up with 0, and so our answer will be equal to 20. And so they ended up with 20 snowblowers in 1 year. If we have a function n of t, another trigonometric function, we can use this to estimate the number of minutes of daylight in a certain city for a given day of year, where t is equal to the day of year. Use this function to estimate the total number of daylights in a whole entire year and compare it to the total number of daylights reported to be 3,000. See how close this estimate came to the actual function. Alright, so if this is the number of minutes on a particular day, let's integrate between 0 and 365 of this function to find out how many minutes, or in this case, how many hours in a given year. We're going to get minutes, but we're going to need to switch it over to hours at the end. So we've got 120 sine of 0.01t minus 1.3 plus the 460, and this is going to be in dt. So again, we're going to write this as two parts. We're going to write this one as the integral from 0 to 365 of the 120 sine 0.01t minus 1.3 plus the integral from 0 to 365 of 460 dt. Okay, this is going to be easy enough because the second one is very easy. We're going to end up with 460t when we take the integral of that one. But let's take a look at this first one for a second. Let's let u be the inside of the function for sine. So let's let that be equal to 0.01t minus 1.3. And let's let the derivative of u be equal to 0.01 dt. And then we can get dt by dividing 0.01 on both sides will give us du over 0.01. So we can rewrite this as the integral from 0 to 365 of 120 sine of u, and then we're going to take out this dt here, and we're going to get du over 0.01. So if we take the 0.01 and the 120 out, that's going to give us 12,000 out on the outside. And if we integrate sine of u, that's going to give us negative cosine of u, and that is going to be from 0 to 365. Plus, we've got over here, we've got 460t from 0 to 365. So let's break out the arithmetic here. That'll be 12,000 bracket minus cosine, and let's plug the u back in there. So that would be 0.01 times the 365 minus 1.3, parenthesis close, minus a negative cosine of the 0.01 times 0 minus the 1.3, bracket closed, plus 460 times the t, which is 365 minus 0. I ended up with 179,990 minutes. And if we divide that by 60, that will give us 2,999.8 hours if we divide that by 60. And you can see this is very close to the original 3,000 hours. So you can see very, very close estimate.